We all know AI is pretty amazing at crunching numbers, finding patterns.
Definitely.
But when you get to the really messy stuff, the nuanced human things like, tough ethical calls or even deciding if art is genuinely good, well, it tends to hit a wall, doesn't it?
It does. Classical logic, it's precise,
Yeah.
sure, but it breaks down with uncertainty.
Yeah, totally inflexible. And then the other side, AI like neural nets, they spot patterns like crazy, but figuring out why, good luck. It's like a black box.
Exactly. You want the precision and the understanding.
Precisely. And that's what we're diving into today. We're looking at this really fascinating paper by Austin Maverix. It's called Quantum-Symbolic Confluence, a unified reasoning framework.
Mm.
Our mission here is to explore how this framework, Quantum-Symbolic Confluence, QSC for short, aims to bring together quantum computing and symbolic logic, the goal, something they call transcendent reasoning.
Which sounds very grand.
It does. And what it means, really, is trying to get past the limits of current AI, even our own human biases, to tackle problems that are just, well, they're currently beyond us. Situations where uncertainty and maybe conflicting information are just normal.
Yeah, and what's really interesting, I think, is how it's designed to bridge those gaps where the traditional systems just fall short.
Right.
This QSC framework, it aims to actually resolve contradictions in these fuzzy domains, as the paper calls them.
Fuzzy domains, I like that.
Yeah. And the idea is to get conclusions that are both, logically sound and adaptable to the context. It's trying to build a system that thinks with, well, something closer to our own nuance.
Okay, so to really get why QSC is such a big deal, maybe we should think about why the old ways don't quite cut it.
Good idea.
Imagine, trying to code ethics into a self-driving car. Like that classic trolley problem, but real.
Right. The impossible choices.
Exactly. Or, less intense, maybe trying to get AI to judge art objectively. Or what about those really wild ideas in cosmology, like the multiverse? These aren't simple yes-no questions.
No, not at all. They need that mix of precision, flexibility, and scale, really, that current systems just don't have.
Yeah.
And the paper points this out clearly. Your classical symbolic logic. Great for defined problems, super rigorous, but real-world ambiguity. Uncertainty. It struggles a lot. Then you've got neural networks, amazing pattern spotters, like you said. Show them a million cat pictures, they learn cat.
Yep.
But ask why it's a cat. Often, you can't get a straight answer. And these existing hybrid systems, the neurosymbolic ones or quantum-inspired AI, they're often still limited, either stuck relying on classical computing backbones or they only work for very narrow problems.
Okay, let's unpack that a bit. So it's about navigating these shades of gray, but with actual rigor. Not just spitting out an answer, but one that feels, I don't know, contextually right, maybe even defensible. How's that really different from, say, AI using probability models? Now, don't they assign likelihoods?
It's quite different, actually. Probabilistic models give you a likelihood, sure, but they still operate on a classical scale. Linear.
Okay.
What QSC is aiming for is a system that can simultaneously explore all the possibilities, even the contradictions, in a way classical systems just can't, and then resolve them into a coherent conclusion. It's more than just probability. It's like the quantum mechanics of thought.
Whoa. Okay, so if classical systems fall short, what's Maverix's grand solution, this QSC thing?
Yes, quantum-symbolic confluence.
The paper calls it a paradigm-shifting framework, fusing symbolic logic with quantum computing. The goal, a truly unified reasoning system. It sounds almost like science fiction.
It does lean that way, doesn't it?
Yeah.
The real innovation, the core of it, is something called the Quantum Logic Manifold, or QLM.
Quantum Logic Manifold.
Yeah, it's a totally new structure designed to encode classical logic rules into quantum superposition states.
So hang on, does that mean logical statements aren't just true or false anymore? They can be. Both. Or somewhere in between, like a qubit.
Kind of, yeah. Think bigger picture. Propositions exist in this quantum state of possibilities. It's not just 0 or 1, true or false. It's a spectrum held in superposition.
Wow. So the QLM isn't just about true-false then. It's exploring all the logical paths, all the probabilities, and even spotting analogies between ideas all at the same time.
That's the idea.
That's incredible. It's like a supercomputer that's also creative and intuitive.
Exactly. Now, technically speaking, the QLM is described as a topological structure.
Okay, starting to lose me slightly.
Okay, think of it like a very complex quantum map of knowledge. Instead of just yes or no for an idea, each concept is like a cloud of possibilities. That's the quantum state in what's called a Hilbert space.
Hilbert space, right.
And there's this mathematical web, a metric tensor, technically connecting all these ideas. It uses entanglement to show how different concepts relate, even if they seem to contradict each other. It's a really sophisticated way to represent knowledge, allowing for incredible nuance.
Okay, I think I'm following. So you build this amazing quantum knowledge base, this QLM, mapping ideas in a new way. But how does it actually think? How does it process all that fuzzy possibility and arrive at an actual conclusion?
Right, that's the job of the Quantum Inference Engine, or QIE. That's the brain that processes the QLM.
The QIE, got it.
So the QIE uses something called variational quantum circuits, VQCs. You can think of them as like adjustable quantum programs.
Okay.
When you give it a query, a question, these circuits guide that query state towards an output state. They optimize based on a cost function, which makes sure the answer aligns with logical rules, keeps consistency with classical logic where needed.
And the quantum part, the entanglement.
Ah, that's key. Entanglement lets the QIE explore all those contradictory or fuzzy inputs simultaneously. It literally holds all the possibilities at once.
But wait, if it holds all possibilities, how do you get one answer? Doesn't it just stay fuzzy?
Great question. That's where quantum measurement comes in. Just like in basic quantum physics, when you observe or measure a quantum state,
It collapses.
exactly, it collapses from that superposition of possibilities into one single definite state. That's how it resolves the contradictions and gives you a concrete output.
Okay. Wow. That's a lot to take in. So let's shift gears a bit. All this theory is fascinating, but where could this QSC actually, shine? What are the practical uses for you, the listener?
Well, the paper dives right into those fuzzy domains we mentioned.
Yeah.
First up, ethical decision-making.
The tricky stuff.
The really tricky stuff. So QSC encodes things like rules, deontological rules like do no harm, and also outcome-based ideas, consequentialism, like maximize the good for the most people.
Yeah.
It maps these potentially conflicting ideas as entangled states. This lets it evaluate the trade-offs, but in superposition. The paper gives that autonomous vehicle example, choosing between, say, swerving towards a pedestrian or risking the passenger. QSC can weigh those terrible options simultaneously.
Instead of just following one hard-coded rule.
Precisely. Then there's aesthetic synthesis.
Judging art. How does that work?
It maps formal things like symmetry or the golden ratio alongside subjective features like predicted emotional impact. These get mapped onto the QLM. Then the VQCs optimize for, well, coherence, essentially.
Wow.
They actually did a simulated experiment mentioned in the paper, generating artwork rankings based on 10,000 annotated images, trying to quantify taste, basically.
Which is notoriously hard for humans, let alone AI.
Exactly. And finally, cosmological modeling.
Like the multiverse.
It's exactly like the multiverse. QSE can model these really speculative theories by encoding competing axioms, the fundamental assumptions of different theories as superposed states. Then it can run probabilistic checks against observational data we do have. It's a way to explore theories we can't directly test in a lab.
It's pretty clear it's designed for these complex, messy problems where normal computers just freeze up or give simplistic answers. But, does it sound too good? Are there ethical questions or art judgments you think would still be too nuanced, even for QSC?
That's a really good point. The paper suggests that within the scope of what has been taught, it can resolve these. But, and this is crucial, the quality of the answer depends entirely on what's in the QLM.
Garbage in, garbage out, even for quantum systems.
Sort of, yeah. If you're missing a key piece of ethical context, or maybe a whole school of artistic thought isn't represented in the data it learned from, then even QSC will struggle. It's powerful, but it's not magic. It needs comprehensive input.
That makes total sense. Okay, so it's not just theory. The paper actually presents simulated results, a proof of concept.
That's right.
They used Qiskit for the QLM, ran the processing the VQCs on a simulated IBM quantum backend, and used a standard logic solver for the classical checks. And they really put it through its pace's 10,000 training iterations.
Yeah, it was quite thorough. And the results were pretty striking. They measured things like logical validity, how well it matched human judgments, contextual coherence, and how efficient it was.
So what did they find?
Okay, for ethics, QSC resolved those dilemmas with 95% logical validity. That's high. And importantly, its choices aligned with human ethical judgments 85% of the time.
How does that compare?
Significantly better than the classical neurosymbolic models they tested against, which hit about 80% validity.
Okay, noticeable improvement. What about the art?
For aesthetics, QSC's rankings achieved a Pearson correlation of 0.92 with human rankings.
Which basically means?
It means its rankings strongly agreed with human preferences. much better than the neural network-only models, which were around 0.75.
That's quite a jump in something so subjective. And cosmology.
In cosmology, it identified consistent multiverse models with 90% accuracy. And interestingly, it did this while cutting the computational cost by 30% compared to classical simulation methods.
Faster and more accurate for modeling the universe.
Okay, here's where it gets really interesting for me. These numbers, they're not just theory. They suggest a system that could reliably navigate ethical minefields, maybe even objectively assess something like beauty, and model the unobservable universe credibly. Tasks we usually think are purely human, maybe even beyond rational analysis sometimes, that feels like, well, a mind-blowing leap.
It really does point towards a significant potential shift.
All right, so we've seen the mechanics, the early results. Let's zoom out. What are the really big picture implications here? How could QSC actually reshape, science, philosophy, maybe even our daily lives?
Well, scientifically, the impact could be huge. It offers a way to do scalable reasoning for incredibly complex systems, think AI ethics on a grand scale, or climate modeling or drug discovery, alongside cosmology.
Philosophically, it's fascinating. It really challenges our standard classical ideas about truth. If reasoning itself can be modeled as a quantum process holding contradictions before collapsing, that could inspire whole new ways of thinking about knowledge, about epistemology.
Or how we know what we know.
Exactly. And practically, applications could include much more sophisticated autonomous decision-making, not just cars, but maybe in resource management or disaster response. Creative AI could get a massive boost. And it supports that speculative science we talked about. Potential in healthcare, policymaking, even generating novel art or music.
Wow. And the paper actually maps out a timeline for this. It's not just someday, maybe.
It does. It lays out a technical trajectory.
Yeah.
Short term, say 1 to 3 years, they're talking about building QLM prototypes on maybe 50-qubit quantum hardware, testing them with smaller data sets for ethics and aesthetics.
Okay, near-term steps.
Midterm, maybe 3 to 7 years. The goal is scaling up to 100-qubit systems, maybe more. And crucially, integrating real-world data, feeding it actual legal codes, huge archives, things like that.
Getting serious data in there.
Then long-term, looking out 7 to 15 years or more, the vision is deploying QSC on fault-tolerant quantum computers. The really stable, powerful ones we're still working towards that could enable global applications, things like complex international policy modeling or detailed cosmological simulations.
15 years sounds ambitious, but also kind of plausible given the pace of quantum development.
It's ambitious for sure, and there are major hurdles.
I was going to ask, can't be smooth sailing.
Definitely not. The big technical challenges. First, qubit decoherence. Quantum states are incredibly fragile. Keeping them stable long enough for these complex calculations is like trying to build a sandcastle during an earthquake.
Right, maintaining coherence.
Exactly. And scaling up. Building quantum computers that are large enough and stable enough is a massive engineering feat. We need big breakthroughs in quantum error correction.
Fixing the mistakes the quantum weirdness introduces.
Yep. And then there's the data. The QLM needs vast amounts of high-quality, curated data covering many fields. It's not just about raw data. It needs to be structured in a way the QLM can use. That's a huge challenge in itself, gathering and preparing that knowledge.
So putting it all together, Quantum-Symbolic Confluence, QSC, it's this really revolutionary idea for reasoning. It's trying to blend the raw power of quantum computing with the clarity and interpretability of symbolic logic.
That's the core idea.
Aiming to crack problems that have just stumped us, maybe for centuries. It makes me I remember wrestling with a really tough personal decision a few years back. No easy answer, right? It felt like my brain was trying to hold 10 different conflicting possibilities at once and somehow make sense of it all. This QSC, it sounds like it's trying to formalize that process, but on an unimaginable scale.
That's a good way to put it. And it really brings us to a fascinating, maybe even unsettling question. If we can build systems that navigate all this nuance, this fuzziness of reality, using this kind of powerful quantum reasoning, what does that ultimately mean for our own human grasp of truth, of morality, of, well, existence itself?
It's a profound question, isn't it? It really makes you think. As we look ahead, it's clear the potential here is immense, but so are the challenges. Definitely something to keep an eye on.